Hello, everyone. Welcome. I'm Bret Brown. Welcome to Pragmatic CMake, how to avoid headaches with simple CMake. I am the lead of the C++ infrastructure team at Bloomberg. I work a lot on build systems as part of that job and how to scale our code base to a very large company of engineers, very large code base. And I also think a lot about how our code base interacts with open source projects, a lot of the same projects that you all use. So CMake, right? It's perfect. There's nothing wrong with CMake. Everyone gets how to use it perfectly, right? Maybe not so much, right? There's got to be some good parts in there, though. CMake experts seem to talk about how it's great. You should learn how to use it the right way. But how often do you get a real how-to guide for that? Probably not that often. In fact, one of the reasons I decided to do this talk was because I was looking at the most recent set of YouTube videos and things like that. And I was finding that it was recommending things that I wouldn't recommend. And a lot of that was good advice, but maybe 10 years ago, give or take, and that we were due for an update. So this is me trying to say, hey, fresh slate, let's talk about how CMake should really work at a very practical level. So, like I said, I work at a large company, a lot of engineers, all experience levels, lots of projects of all different kinds, different sizes. And it scales well. And the reason it scales well is because we keep it simple, because we don't overcomplicate every project. And we try to keep, and that really helps. And while you may not be working on that many projects, you may not be working on that big of a code base with that many people, it's not like you have a lot of time to fiddle around with your build system, right? You want something that kind of gets out of your way and mostly lets you think about the problems you're actually trying to solve. So what I'm shooting for, because I work in a developer experience context, is I'm looking for that developer experience. I want you to think about the problems you want to think about and not think about the tools that go around with it, right? So the roadmap for this talk is this. I'll be front loading the talk with some resources you can go to, some communities to plug into. Then I'll talk about CMake workflows and how you can best leverage them. I'll hit on some principles for you to think about when you're deciding, does this go into my project or not with respect to CMake? And then I'll do a walkthrough of an existing project that you can maybe use as a reference for yourself when you want to see, what am I doing and what is this project doing, and kind of give you a benchmark to compare your work against. As I go through the talk, watch out for this sparkle Unicode emoji. That means something that I think is probably undertaught, or even it's brand new, maybe something you've never seen before. So if you've already been using CMake for a while, unless you're the kind of person that watches the release notes and makes your own notes for later, these might be things you've never seen before. Also watch out for this icon. The magnifying glass is to show that this is a real piece of code, as in I got the line numbers right, unless I had a typo, from the Beam Exemplar project. I'll talk about that project in more detail, but it's from the latest release, the one that I pushed today, which is 2.1.1, and there's the commit SHA if you really want to double check my work. You can go find it and follow along when I get to the example section later, in case you want to see the whole file in front of you or something. So on to the meat. Resources. These are all resources I like. CMake has a discourse. You may not be aware of it. Thank you to Kitware for hosting that, making sure there's a place for people to get support. There's a book called Professional CMake by Craig Scott. It is very in-depth about all the features you might want to use in CMake and some that you probably don't want to use, but it's all in there. He keeps it up to date every time CMake has a major release. As far as I know, he goes through, makes the adjustments he thinks should go in that book, and he keeps it up to date. It's self-published, so you need to go to his website and you can buy a copy of it, but it's worth it. There is a CMake channel on the CppNow Slack, sponsored by the C++ Alliance. It is relatively active. You will see CMake core developers hanging out on there and helping answer your questions if you're more of a Slack interactive chat person compared to a forum discourse kind of person. And then, of course, there's the CMake repo. It's not on GitHub. The official repo is actually on a Kitware-hosted GitLab instance, but you can go there and file issues. Something's confusing, you have an idea, you want to fix a bug, suggest a bug, that's a good place to go. By the way, I have a lot of these QR codes for things that make it easy to jump to with a little description at the bottom. This one in particular is the QR code to a gist for these links. So you're probably not going to type these down really quick on the slide. So if you want to take a picture, that's fine. Not recommended as much. CMake on Stack Overflow, I find most of the important questions were asked 10 years ago. And the answers that were answered 10 years ago float up to the top and were pinned as the correct answer. And they may not be the best answer anymore. It might be functional, but maybe not what you want to do. And the large language models I've used so far seem to be trained on maybe that data and similar quality data. And they likewise will recommend relatively out-of-date things. That being said, that's a fast-moving part of the industry. This might be out of date by the time I get to the end of the talk. So let's talk about using CMake, the command. Like, how do you drive CMake? These are the steps I want to get through. You don't have to do them in exactly this order, but more or less, this is pretty much how you're going to do it. So we're going to talk about provisioning, as in where do your dependencies come from? Where does your build environment come from? How is that set up? We're going to talk about configuration, where you make a binary directory for your CMake project. We're going to talk about building, where you actually make your executables and libraries and such. We're going to talk about testing. We're going to talk about static analysis. I don't have time for all the other kinds of analysis, but static analysis is kind of the bare bones for any project, in my opinion. And then we're going to talk about the installation, packaging, delivery step. So when you're provisioning your environment, we're talking about preparing your development environment, right? So like you need to pick a machine to build on, what OS is it on, the chipset can be pretty relevant depending. You definitely need your source code. So you can't just go on the box into the default directory and hit CMake because where's your code, right? And then you need the dependencies to match those things, right? You might need specific dependencies for specific OSs. You definitely want dependencies to match that version of your project, right? Something that's interesting about all these steps is they all involve some amount of, at least conceptually, going off of your machine to fetch some information and bringing it back to your machine. And that's what ties all these things together. And it's kind of complicated work, but it's very critical work because it kind of sets you up for success in the rest of the workflow. It's very hard to run your unit test if you don't have your test driver installed as a build dependency or something. It's important to understand conceptually that the environment you're building in is driven by the needs of your ultimate task or your ultimate executable even, especially when it comes to linking. So I don't have time to go into a ton of detail on all the reasons this is true. I could fill a whole nother talk up with that. But it's important to remember that this is a property of building programs that you need to be consistent about these details. And it's not just a matter of taste or some idea of aesthetically pleasing CMake or something. When I get into the details later about this thing should be spelled that way, it's entirely so that we wire up all these steps together so that you have success at the end. And that you can really drive those requirements from the end state back to where you started, back to where did you get your dependencies from, for example. And again, that's already touching on some of the complexity. Do all your dependencies even work together with the versions you're trying out? A lot of times the answer is no, and it's your job to figure out what to do about that. But they can also vary based on what you're doing. Like if you're doing static analysis, you might need different things installed. If you're doing coverage analysis, you might want a coverage reporting system that you would never really put in your production build environment because you may not need that for that situation, right? So it's important to note that it's not just a property of the project, it's also a property of you, the person interacting with the project, what needs to be provisioned. And while this part can be complicated, so you should be thoughtful about it, it's often not really that bad if you express yourself well and you set up your build dependencies correctly, or your test dependencies, your analysis dependencies. A lot of the workflows are pretty straightforward, as in for the exemplar project, it's basically walk through the tutorial for that technology and you'll be set up for success. So just to pick an example, if you're not an Ubuntu image, WSL or otherwise, you might need to install the libgtest-dev package to make sure that gtest headers and libraries are installed so CMake can discover them and use them for you. But to use the last bullet point, maybe you wanted to use something called fetch content. You may not be familiar with it, but it's a thing that will go to Git and download things for you. That may also resolve your problem. So there's more than one way to solve it if you do this correctly. So that's all. I didn't talk about CMake in that whole section because for the most part, it's best if you don't write any of that information in your CMake, right? Instead, focus on this step as the entry part of your CMake, the configuration step, where you make a binary directory. If you've gone through a CMake tutorial, you've seen something like this before. Although, I put, this is our first sparkle emoji stuff. A lot of you probably aren't typing it this way. In fact, a lot of tutorials I see, even one I saw on YouTube this year, have a different workflow that involves changing your directory, and that is no longer needed. Especially in a CI script, it's very helpful to not have to do that. So what you can do is to provide a $B to point out your binary directory that you want to create or fill up, right? And then -S for where your source code is. Your CMake, where you're running, doesn't matter. Your current working directory doesn't matter from a CMake perspective, at least as far as, unless someone does something they shouldn't really. And then you build on top of this, basically. So the rest of this section will be like different things you should think about. You provide different options. It's worth noting, in particular, the $D is to provide CMake variables, sometimes called cache variables, to configure your configuration step, right? That's why it's called the configuration step. They are key equals value pairs. Oftentimes on the right-hand side, you'll get some sort of a truthy value. On is fine. It's really obvious what that means. Almost always, you're going to want to set a generator. Again, if you've been through a CMake tutorial, this doesn't surprise you. What might be new that you didn't know was that you can set your CMake generator from an environment variable, which I happen to like. Very rarely do I vary that between the different project builds I do. So why would I type that every time I type the CMake command? So why not just set that in your dot files, in your VS Code settings for your user, that sort of thing. I like to use Ninja, so I'll put Ninja as my default generator. On at least POSIX systems, which a lot of people use, the default's going to be Unix makefiles, which is not generally recommended for by people these days. Almost all the other options are better at this point. Ninja, or for the IDEs that are supported, that IDE is probably your best fit for you. Note that there is a Ninja multi-config generator. Isn't super new, but you may not know about it. So if you find yourself juggling a lot of like both flavors, like debug, release, other things, like check that out. Check out the docs for that. It should be pretty straightforward how to use it. Something else you're always going to say is the build type, right? There are a few build types baked into CMake, and they're hopefully self-explanatory. Maybe you're doing a debug build or a release build, right? Again, it's available as an environment variable. This is something we found very helpful in Bloomberg, so we went ahead and sponsored that work along with Kit, where we teamed up and added that as a feature. It was a pretty quick win. So you're always going to set a build type. One of the big, I bring this up because for a lot of people it's review, but it's actually one of the biggest problems people have when they pick up CMake the first time. Is they're like, I didn't set a build type, what's going on? And they're like, what just happened? What did it configure? And the answer is it configures compiler defaults. Whatever your compiler does by default, we'll just let the compiler do that. And that's confusing to people. So almost always you want to just set a build type. If you don't have an opinion for local development workflows, debug is great. Go with that. If you're using the Ninja multi-config generator I talked about, you're not going to use the CMake build type variable. There's a different variable that has the semantics of a list. So you can list more than one build type, basically. And it's called CMake configuration types. Also available as an environment variable. So CMake also has toolchain files. These are fantastic. They're underused. I'm not going to be able to go to much more detail than this in this talk about it, but you should be aware of them, especially because a lot of tools like Conan, VC package, and that sort of thing use them to inject context into your build. So they'll know you're trying to do a release build. They will tell you what the settings are for your release build through a toolchain file. And this is really helpful that you don't have to put all that information in your project. Your dependency manager will take care of that for you. So it's an ideal place for all the ABI affecting settings. As in, don't put them in your project. The toolchain file is the right place to put that sort of thing. If you do want to like literally set flags for your compiler, this is actually a better place to put it than most of the time what I see in CMake code. It's generally not a good idea to put a lot of compiler fiddling options inside your CMake list.txt. I see that a lot in a lot of open source projects even. It's just really not portable. It's hard to maintain all the possible things you might want to do, all the possible versions of the compiler. But the thing driving the CMake command knows what compiler it's trying to run. It knows that kind of, it knows whether it's trying to do a production build or a sanitizer build. In this case, it's what this flag does, new GCC 15 feature, you could get your normal build warnings and errors, but it'll also add a JSON file to the side that provides a structured version of that same information for your IDE or your CI system, for example. That's not something you want to put in your CMake, is it? I wouldn't want to, but it's fantastic if your IDE knew how to wire that up, and that's why these things exist. This is another, I'm bringing this up as well. This is something that Bloomberg sponsored again, because we had this issue. It's very common that people try to manipulate the W error flags in particular in their CMake list.txt, even hard coding it always on, which is actually really hostile to your users, because they may be doing something you didn't anticipate they would do, like use GCC 16. Has anyone validated that their warning's clean with their GCC 16 build yet? Any hands? Why not? Because it doesn't exist yet. So how can you promise? Yeah, right. So how can you promise you're clean of all the warnings in GCC 16 if those list of warnings hasn't even been written down? And that's the problem, right? So that's why it's better to set it in your workflow. Plus, I don't know about you all, but sometimes I want to refactor my code, and I don't want to fiddle with all the unused variable things while I'm moving things around. And so it's really a workflow setting. So this goes back to my earlier slide about how things vary depending on what you're doing. Well, sometimes it varies not on the person, but what the person's doing. I don't want to do warnings as errors now. I'll do it before I commit. But right now, get out of my face. So this is what this does. So what you can do is you can set compile warning as error to change the default for your project so that warnings as errors is on by default. But then there's another flag you could provide from the command line to say, yeah, but never mind, I'm busy. For this build, I want you to return 0 if there's warnings. It's okay. So you really can let your build system take some of the load off of the complexity of your project management. And I don't know a lot of build systems that have this feature. In fact, only CMake, maybe some other ones do. So it's really worth looking at. Yep.
Will that actually cause it to ignore, if the user then tries to go in the CMake list and say, I do want to compile warning as error, does that override?
It works if you use the compile warning as error property instead of setting W error. So if you hardcode W error, it doesn't work because CMake's not going to rewrite your flags. But if you use the CMake property, which we'll get into properties in a minute, on relevant targets, maybe you only want it on your production code but not on your test, you can do that. But that says for those projects, if you see a warning, that's an error. And then this will say, never mind, right? Yep.
Can you go back to 24? Would this line be recommended in a toolchain file instead of whenever you invoke the CMake? Assuming you have a toolchain file.
This setting would be good in a toolchain file.
Okay.
So what the CMake compile warning as error does when you spell it this way is it says it's the default for all the targets in your project. If you set it as a property per target, that's per target, whatever you set that. I have to move.
Sorry,
yeah.
Can I ask a question?
Yeah.
Can you go back?
Uh-huh.
You mentioned compile warning as error, but you don't mention link warning as error. Is it on purpose or?
I didn't just for time, just trying to move on. Yeah, but yes, there's a link warning as error too. All right, so now that's the configure step. That's the most important thing of the whole workflow is that you get your configuration settings the way you want them for that build. When you do build, there's the CMake -- build command, which abstracts away whatever your underlying build system are for the command line workflows at least. So you don't have to care if you're Ninja or Make. So again, a lot of tutorials will say, run make in CD and then make or something. You don't have to do that. Just say CMake -- build and give it your binary directory. Especially great if you have more than one binary directory for the same workflow. By default, it'll build an all target, which it borrowed the name from Makefile if I'm not mistaken. And what that means is build all the default targets, basically. Note there's an exclude from all if you have special targets that shouldn't build by default, like micro benchmarks or something that have special dependencies. If you want to, I got this one wrong. Dang it. All right, so this is not the right flag. So if you want to see all of your compile commands as you build, don't spell it this way. Spell it -- verbose. I don't know how I got this. I got this right once, but I must have deleted my change. So, but there are a lot of default targets also. Note that all clean, test, and install are all first-class targets in CMake, and you can wire things up to each of those targets. To clean your project, this is, again, something you may not be aware of. You don't have to do a multi-step thing. You can just say clean first as a flag, and then when you run build, it'll clean and then build. That's really nice. Again, this is something I sometimes see people mess around with CMake list.txt trying to fiddle up clean logic, and don't mess with it. Here's the verbose flag. If you don't want to type verbose every time you build, you can set this other variable to say just verbose makefiles by default. So you'll just always see verbose. It's spelled makefile. It works even if you're using Ninja. So that's building. That's the very quick version of how building works in CMake. Quick side note, is CMake a build system? I mean, I didn't mention the build system so far. It's abstracted away in Ninja makefile. Well,
It's a meta build system.
is it? Because I
Yes.
I just drove the build.
It is a configuration system.
It's
Think
a
autoconf.
It's a configuration system.
Autoconf.
All right. Well, I didn't mention the build system so far. Just saying.
Don't think autoconf.
So for test workflows, super important. Test your code. Very much please test your code. Other people building your code, maybe in a new OS, maybe in a new compiler version. They want to know if they did something wrong. Maybe they're trying to give you a change. They want to know, did I break anything? Please add tests. Always. Like add 0 tests if need be, right? So, but if you want to run the test, there's 2 ways to do it. They're both nice. The first one has a little more options to it. The second one has the familiarity of being a lot like the build command. They'll run the registered tests that are hooked up to the test target that I mentioned. There's a lot of nice features, if especially when you use the C-test version of the workflow, because you can say, oh, I want to see tiny output, but lots of output if there's a failure. There's a lot of cool options. If you haven't read through the CMake C-test -- help, there's a lot of cool stuff to look at. Filtering, randomization, run it in a loop overnight until you get back in the morning. Lots of cool things you can do. But one of the big things that I see people have an issue with when they start writing CMake, like as a new hire at a school or something, is they get this error, which says, could not find executable, something not built. Well, maybe you can guess, but what it means is that your tests weren't built. Why not? Well, tests don't build the test target doesn't actually build your tests, right? At least not by default until there's now this new setting, brand new. You might even have to upgrade your CMake to get this version, to get this feature. Where if you set this to off, which is unusual for a feature flag that you're turning it off because the default's on. The default on is to skip that dependency that you would expect would be there. So if you set it to off, you'll get the dependency that you wanted. So if you run the test command, it'll build your tests and then it'll run your tests. So you can, yeah.
Wait, why would you want to run tests without building them?
Sometimes you want to run the test without building them. It's a little esoteric, but like if your build's like super slow, but you know you only want to run like that one little test that you're trying to fix. I don't think it's the right default, but that's probably why they're adding this feature. Maybe someday in CMake 5.0 they'll flip the default.
Yeah, why not make what we want to do most times the default?
Yes.
Just build your test.
Right. The core engineers at CMake also agree, but it's one of those how do we get there from here problems. Yeah.
How new is this?
Like 3.28 or something like that. It's like a year and a half old, maybe. I'm guessing. I probably should have written all that down, but at some point it's like washes over you kind of thing.
Right.
Yeah.
Some of my tests can't be in all because they test compile failures.
Yeah.
So I run them via C-test, but is there a way to... I guess C-test already takes them into account then, and the rest get built.
So C-test is super configurable. That's a whole other talk. In fact, I've given a talk internally about C-test, but you can actually set up C-test to expect a failure condition for a compilation command, for example. So that would not be a failure. It would just be a successful non-zero exit code.
Right.
Right.
Besides having like ergonomic filtering and stuff, is there like a fundamental difference between C-test and CMake test target?
Like this feature. Wait.
No, or just C-test by itself. What's the difference between C-test and
C-test also has a lot of other workflow features baked into it that you could choose to use. CMake -- build is just a more straightforward, I want to run the test target thing. For the most part, you can use both. And for most normal workflows for projects where the tests are reasonably fast, it doesn't matter. Just pick one. I would lean towards C-test just because it has more options for the most part. Although the nice skip test all dependency, as noted in the bullet point that I didn't say out loud, doesn't actually work for C-test. I don't know if that's even possible to implement because of implementation details. But if you like that feature, then definitely use the test target using the build command. So static analysis. Again, I see a lot of people writing a lot of code in CMake list.txt over and over and over and over across all the repos to get static analysis just the way they want it. And you may not know you don't need to do any of that. So there's two primary ways that you would wire up static analysis to your project. One is to use the standard, de facto standard, I guess, to compile commands JSON file. What that is just a JSON file listing all the compile commands you would run for that build, for that project. It will include commands not in the all target, by the way. And what it does is it's just an interop standard. So something on the other end can see those and make use of it. C++ is a complicated enough language that you need that context to parse the code accurately at all. Like you need the preprocessor settings. You need to know which include directories were being used. So what this does is it lets lots of tools, like your favorite IDE, your favorite language server protocol like ClingD, your favorite static analysis tool probably supports this. And if it doesn't, you could probably put it in the issue request and everyone else will upload it because it's about time that they do. You can also, Sparkle emoji, you could set this as an environment variable. When would you not want this set up? I always want it set up. In fact, your IDE probably does it for you automatically. Set that in your dot files. Don't even think about it. So when that's set up, you'll have the compile commands JSON in your binary directory. You can use your favorite static analysis tool to point at it. Look at the docs for your tool, like ClingTidy has a -p for path to point at the directory that contains that file. And that's about it. If you want to do something even more, hey, Bret, that's a lot of typing. I have to write ClingTidy-p. Come on. Like, all right, so you can do this. So you may not know that you can set CMake cxx ClingTidy and give it a fragment of a ClingTidy command. It will what they call co-compile, meaning they'll run that command as part of your Ninja build graph in parallel to your actual compiles. So you'll warm up your cores a lot more when you're doing your builds. But you'll see right away, like as you're hitting your save and build loop, ClingTidy didn't like that you used the null all caps spelling instead of the null putter modern spelling, that sort of thing. There are analogous settings baked into CMake for CPP check and include what you use. If you want to add something else to the list, that's a great reason to jump in the kitware backlog and start making suggestions.
So if I want to use all three, do I just like put that 3 times on the command line or comma separated?
There are 3 separate variables. So you can do all 3 variables. They're spelled differently. So this one makes it. Yeah. All right. Now shipping your code. Again, built-in target for installing. That's really helpful if you're using a build system that does not have a baked-in install target like Makefiles. Maybe consider a more modern build system. Important to note about the installation step is it's not just about relocating the files. It also prepares them for the production environment. For example, in certain architectures, it will rewrite your search paths for dynamic libraries to map what it's going to look like on your production box, not inside your build environment. Does that make sense to everybody? Because your shared libraries might be in different places depending on where you're working locally, right? You're iterating. Might be a different place than where it is when you actually ship into like your container or whatever else you're shipping to. This is what it looks like. CMake has a -- install this is kind of how you do a subcommand in CMake. So CMake -- install, and then the binary directory again that you configured previously. There's a lot of little settings here. By the way, this is a form that you may not see in your tutorials. It might say make install or something. Why don't I want you to do make install? You can. This has all the features you want. Like destdir is great. So destdir as an environment variable, and you put it where you want it, right? You want it in temp foobar, fine, put it there, right? There's a prefix setting. What that does is to describe when you install, like what would be the prefix of the install. So like you'd have a bin directory maybe for executables. You'd have an include directory for headers. But what's the directories ahead of those, like above those? Well, it might be user local. It might be user. It might be opt something, right? Well, that's what this prefix is for. By default, I believe it's user local, which does not match everyone's expectations in particular. That's why I brought it up. And you can do just a plain / if you don't like prefixes. Less featureful, again, you can do a build command with a install target. You just don't get all the nice options that you might otherwise get. And analogous to the test target, it doesn't build your targets before it does the install, unless there's an analogous CMake variable you can set. Yep.
I was just going to say another little sparkly thing.
Yeah.
There's also install/parallel nowadays if you have a very large install.
Oh, nice. Yeah, I never had that problem, but I bet you
Yeah.
did.
We did.
So there's a parallel install now. That's awesome. Yeah. All right. So let's talk about principles. No, that was a lot, right? There's a lot to go through. I did that pretty quickly, but there's still a lot of little features to know about. We're on slide 42. How much CMake have we looked at? Have I shown you any CMake syntax yet? No. Not an accident. So the principle is, like, keep it out of your CMake, basically, right? Like, I don't want to see interop logic support. Like, I would discourage algorithms, loops, right? Like we want declarative CMake. We don't want you exercising the Turing completeness of the language inside your project, please. Sometimes it's okay to use a variable or a conditional on a variable, but even that, you should be tasteful and minimal as much as possible.
And the ray tracer is really cool.
Yeah, you can implement a ray tracer in CMake. Yeah, please don't ship it to production. So your day-to-day workflow should look a lot like, I added a source file, I added a test, I fixed the test. It should not look like I implemented a JSON parser from scratch. By the way, CMake has a JSON parser. You don't have to implement it anyway, right? It's a CMake lists. That's why it's called lists, because it was always intended to be a declarative thing, right? Important also is don't break CMake workflows. I walk through a lot. There are even more documented that your users want to use. And if you get too opinionated in your CMake list.txt, if you start hard coding things, you break features for other people. And maybe you don't care, but your users do, right? That user is the person sitting next to you, the person that might want to help you package your project next week, that kind of thing. It's widely documented throughout the CMake reference docs that you should not use variables that start with CMake underscore inside your CMake list.txt. And I see that constantly. Like people think CMake gets the wrong defaults or something, and they'll fiddle with the build type. Right? Like, oh, my build type's always debug. Like, well, why would, I can set that. Well, I didn't need you to do that for me, right? So avoid those in particular. If you see your colleagues setting those, that's a great reason to request changes on that pull request. CTest edition of Don't Break Your CMake Workflows is, the workflow is I build, I run the test, it returns non-zero. If you don't have test wired up, it does not return, it returns zero, right? I run your test, returns zero, that means everything's okay, right? If you break that because you don't have tests, it will return non-zero because you never turned on the test target. So by default, CMake doesn't even create the test target. You have to tell it, I want a test target. I'll get to that later. But what you want is, if you don't have tests in your project, you should feel bad. But also add turn on the test target and add zero tests to it, because that's a useful piece of information to say, oh, this project has a test workflow. It works. It just has zero tests. And at the scale that I operate at, that's a piece of data I can work with. I can go talk to people and say, hey, did you know that this project has zero tests running successfully? What can we do about that? If the test target's broken, it could be any number of things, right? If you want to conditionally add tests, which happens a lot for tests, because maybe they're integration tests, they need to run in certain environments or something, you can use options. So this is a CMake option. First actual code snippet. Daemon Exemplar has an examples directory that can be turned on and off if you want to. This is one way to express that. Hopefully it's pretty self-explanatory, except for the project is top level part. That is optional. You can always just pick a default to be on or off. But in this case, the maintainers of the project wanted to make sure that if you subtree installed Exemplar into your source directory, the default was off by default, but on if it was the top level project, if that makes sense. So that's a magic CMake variable. You can go read the reference docs on that, but it is what it sounds like. Is this actually the top level CMake list of the project, or is this somehow in a subdirectory? So this is my slide on fetch content. It's really highly recommended among me and the core maintainers of CMake that I talk to on a regular basis, and a lot of other people besides, that when you want to say I have a dependency outside of my project, you spell it find package, and then the documented way to spell the name of that dependency called the find package name for that project. So it might be FMT for the FMT project, or Google, or GTest for the GTest project. All right. You can write fetch content. It is a feature that is available. What that does semantically, at least by default, is it does get operations to download that target, build it in hidden ways, and then come back and wire it up to your project. But that's an off-box operation, right? That's a provisioning operation. And I'm encouraging you not to do that in your CMake list.txt because it's one of those things that needs to be configured, and then you're dealing with a lot of interop problems already, right? There is something called CMake dependency providers that lets you go both ways. Make one of them look like the other. It's a more intermediate to advanced workflow that I will not have time to go into, especially because this is more of an introductory broad talk, but it's worth noting it exists. It's fairly well documented in the references for the kinds of people that want to do this kind of thing. But there's ways to basically hook into a find package call and say, yeah, no, that's a fetch content. But find package is what you want to spell. It's more declarative. It doesn't say go use get to get things. It just says I have a dependency. That's more declarative. It's simpler to support. It is easier to turn it into a fetch content than the other way around in my experience. And it is more future-proof. It is an API being targeted for things like standardized C++ package management and that sort of thing going forward.
Is there a story behind why the find package and fetch content is camel case versus snake case?
Why is find package snake case and fetch content camel case?
Is there a story?
I think it's just like different generations of CMake development and how their standards were developed over the years. Okay. They're both function calls. Well, actually, fetch content is not even spelled that way. To be honest, I didn't have time. I should have. It's called like fetch content _ declare or something like that.
Oh yeah. With all uppercases. It's because we are.
It's camel case uppercase.
Because we're human. That's why.
What?
It's because we're human. CMake developers are human. We make.
We could go make aliases for all those if people care that much, I guess.
So the CMake commands are not case sensitive anyway.
CMake commands are not case sensitive. If you call it so you could spell it all lowercase and people think you're weird, but yeah.
Right? Is there?
Yeah.
But there are some cases for fetch content, like.
Well, hold that thought. I got a lot of slides.
Okay.
Think about it, and then I'll call on you first when we get to the extra time. All right. So the other thing to really watch out for is sensitive compile settings in your CMake list.txt. I already mentioned ABI settings go in your toolchain files. As a category, anything that, like, if you get it wrong, something blows up in production, probably goes in your toolchain file as a rule. Like architecture tuning flags probably don't go in your CMake list.txt. C++ standard, surprising to a lot of people, does not go in your CMake list.txt. And even some of the CMake core engineers might disagree with me on this point, but like it is very common for projects like Abseil, Boost, Beam and libraries, FNT, other projects to either directly change their ABIs depending on that setting, as in if everyone that ever links that thing in that same program gets it different, they might get an ABI difference, right? Or they're designed in such a way that they really expect their users to be doing that anyway. Like they're a drop-in replacement for a standard thing, a backport for a standard thing that you'll get in a future standard, that sort of thing. It's very common. So you should really treat the C++ standard flag as an ABI flag. At any scale, at a small scale, you're using a compiler explorer example, whatever, but you're not shipping that to production anyway, right? So the Beam and standard has this principle in its coding standard for this reason. If you're interested in the Beam and coding standard, there's the QR code for that. But it's called passive projects to kind of get at, well, the project should be less opinionated. So the thing organizing the whole build should be the one that makes that choice. It's okay. And you might be confused, like, well, what if I only support C++ 17 or newer? Well, be defensive. Like, write your CMake. You can write in your C++ if you want to. Just fail to compile if it's not in the standard range that you support. That is actually more portable than trying to fiddle around in your CMake list.txt. Right? You can change your whole build system. And that feature would still be available going forward.
Yeah, I was going to ask that question.
Yeah.
I think in some of the projects we are writing in the CMake list that if you don't have like C++ 20, right, we're just going to abort because we require a minimum of C++ 20.
Yeah, I don't remember if Beeman has this, but I don't know if Exemplar has this, but there are Beeman projects that do that defensive checking thing. It is also possible to write it as a library feature, and that might actually be an interesting Beeman library to just have like an expression saying, If it's less than this, then fail to compile.
Yeah, you can put it in the header for sure.
It might need to be a language feature, but you can implement it as a macro, as a Beeman library, as a proof of concept or something.
Yeah, there's the language macros which tell you that. So
yes, there's language macros that tell you the version, but there's no language feature that fails to compile if it's not in the expected range, which would be what we would be looking for.
It's a good question whether it should go in the code or the
But you have the same on CMake level. You can say that your target minimum CMake
Right.
plus 20, for example.
I'm trying to decide if I have enough time to get into that. It doesn't do exactly what you would expect, though. It'll pick a. The problem is each project that CMake doesn't have enough context in the process of building any individual project to know what all the other projects were doing. So if you set your minimum required to like 17 and it picks 17, and then another project sets it to 20 and it'll pick 20. So even if you set required, like a hard fail if it's not available, like you're still getting different C++ standards. And that also goes for the features, the feature settings. Is that what it's called?
Yeah.
Compile features.
And they'll decay as well if the compiler doesn't have an explicit way to set them.
Yeah. So the only thing that really makes sense would be either set CMake CXX standard as a configuration time setting passed in, like in your toolchain file, or something at that level where you're passing it into the project. Which is confusing because the docs don't tell you any of this. So that's why I'm giving this talk, among other reasons.
Wait, so if my library required, say, like needs to have 20, and there's another library in there that can't.
Okay, if you need 20 or newer in some project, it only goes up to 17. That's just a conflict. You have to fix it. Like CMake's not going to be able to help you with that.
But CMake will the way you express that in my library is a way to
what should happen is
fail.
What should happen is some high level of context, like your toolchain file, will pass in 20, for example, and then the 17 one will fail to compile saying, I only go up to 17, and then it's not confusing. You just have a conflict. Whereas if CMake just picked things, it would link together, and you might have ABI issues, and then things crash.
Right. And so the right way to express this is in the configure step is to say, this is the ABI for my project.
Right. Way back when you're picking like what chipset you're supporting and like what versions of the key critical libraries you're using, you also pick your C++ standard. And then that flows all the way through from the top. Make sense? All right. And that's what the Beeman standard does. If you go look in the Beeman projects, we generally don't, anywhere I've seen that we haven't been setting this, it's always in like the GitHub Actions or something where we wire that kind of thing up. And in fact, it's great for the GitHub Actions because we wire up all the versions, right? So we do all the ranges that we want to support and make sure they're all supported by the Beeman projects, which is perfect. Yeah.
So Bret, so some things like if you wanted to use like C++ modules, say,
right,
you're going to have your standard set to at least 20.
C++ modules, you're going to need, you should restrict when modules are on, at least you should have some kind of defensive check saying, for no other reason to give a good error message to the user saying, please use C++ 20 or newer, because whatever compiler error you get if the module fails to parse is going to be worse probably, right? So yeah, but that's another setting. Modules are not, which I didn't get into this in this talk, but like that's another provision time you have to decide because you need to know, do I need the modular version of that dependency or the non-modular version of that dependency? So you have to go all the way back to the provision step. And again, this all seems complicated, and I'm explaining it so I convince you all not to put it in your CMake lists.
Just a comment. If you're still interested in this, there's a whole GitHub issues thread where David, Bret, and some other person who's against this, we chatted about it, and we haven't PR on how we should be approaching it. It's just having some minor design issues that we're going through.
And again, this is not a property of CMake. This is a property of linking programs in C++. So I know that like system package managers and like Linux in some cases don't get this detail exactly the way I'm describing it. I would recommend they rethink that because it's not a property of anything particular about the way I'm doing dependency management or doing CMake or any of that kind of thing. It's just the way programs need to link. So visually, the same information, CMake can do all of that. You can write and again, you could put a ray tracer in there, right? But really what you want to do is this. Everything from like the configure step right up to that install step. And again, declaratively, how these edges line up in these boxes, basically, right? Everything else, there's another tool that's going to be better for that. In fact, in some cases, even like making a top-level make file that drives CMake is a better solution than putting it in your CMake. Because then at least everyone else can still run the CMake the way they need to, right? All right, so on to the actual code part. We've only seen one code example so far. Now we're at the actual code part. So this is the Beeman project. The example comes from the Beeman project. The goal of the Beeman project is to make it more ergonomic, more accessible, have a better community around standardizing C++ library features. CMake is not a core goal of the Beeman project. It is a good example, but I'm bringing the examples out of this because it's not a core goal. It's not trying to be clever. It's just trying to do the right thing in a normal, as boring as possible way. The exemplar project is the example project for a Beeman library. So it exists for the purpose of being that demonstration, that base point for the other work to build on top of. It's entirely, if you look at the issues, the pull request for this repo, it's entirely tooling, CMake, package management, those kinds of issues. So that's why it's worth looking at, because it will evolve as we get better. As CMake improves, as we get better at packaging, you'll see it evolve. You can come back to it and say, hey, these things are new. Is this something I can take and use in my projects too? The goal is to use industry standard tools and technology. It's an explicit goal of the Beamer project to not get too clever about any tooling. If you see us being clever, it's because we didn't have any other options. And probably whatever we did, we're going to go to the upstream of something and say, hey, this is actually a use case. Can we make this better supported so we don't have to do this in every project, right? That's the QR code for the exemplar project. If you're the kind of person that likes a little more context through examples, you can open up the project and look at the CMake in context. It's a lot to put on the slides, so I'm more of a snippet-oriented demonstration for the examples. So, preface before we get into the code, it's important to pick good names for all of your entities. Remember that graph I was showing you of all the nodes and the edges? Like those things run on names. Like those edges need to point from one name thing to another name thing. So it's really good to have intention about these things. Put them in your README. Consider changing them a breaking change, right? So the Beeman project, we have a get URL. That is the get URL. If it changes, we should make a breaking change announcement that, hey, by the way, if you have URLs in your repo somewhere, we moved. Go change it to the new URL, that kind of thing, right? So like a VC package, what they call a port, which is a package, they call it a port. We're going to use a hyphenated Beeman-exemplar. For fetch content name, if you want to use it as a fetch content, it is supported. It will work. As a dependency, that's how you spell that one. I got it right on that slide. But it's Beeman.exemplar is the fetch content name. Everyone use it the same way, otherwise fetch content doesn't work the right way. Now let's talk about in the resolution step, the configure time settings. These are all off-box operations. You're going somewhere else to get code, right? These are the configure time things. Our CMake package, if you're calling find package, you're going to use Beeman. Most of these are Beeman.exemplar unless we couldn't. The CMake target, like if you're going to depend on a CMake as a dependency from your executable or your library, Beeman-exemplar is spelled with double colons. That's the normal namespace target name pattern for CMake. And then for CPS, which is the emerging, we're working on, as a bunch of us are, standard for C++ dependency management interop using JSON files. It uses 1 colon instead of 2. It's a similar idea. These are really important to think about. The includes are actually important. They'll come up in other slides. Be intentional about how your includes work. It is one of your APIs in your C++ code. In Beeman project, we run it. It's always Beeman / something. So it's usually Beeman / specific project / and then some header file name that you want. So Beeman exemplar identity. Beeman, I didn't mention this, I guess, implements the std identity for almost identically for no reason other than we needed some code, right? It's a trivial thing to implement. The C++ types are going to be equivalently namespaced in unsurprising ways. So this might be a little bit of a dull section, but that's great. You run really boring names, so I highly recommend that. So with that out of the way, we can look at CMake code. When you're writing CMake list of text, always make a top-level CMake list of text at the top of your repo, as much as humanly possible. It's just where people expect to find it. The first interesting line of code should be setting your CMake minimum required. What that provides you is some protection against CMake upgrades breaking your code unexpectedly. It is used as kind of a feature flag. As you bump those up, you're opting into newer features and opting into newer deprecations. So you do want to bump it up because you don't want to be 10 years behind in your deprecations. If you don't believe me, ask everyone going through CMake 4.0 upgrades right now that learned that, oh, wait, I can't spell strings that way. When did you do that? And they said, well, back before COVID, the your favorite football team was actually good back then. That kind of thing. So what's a good setting? Well, you can go to all your environments and run CMake -- version. Technically, would be the best. Just take the minimum of that. 2 to 3 years is probably okay. But if you're only supporting a few versions, like environments, yeah, just put the newest one in. That's great.
So, question.
Yeah.
Do you actually recommend against giving a version range?
You can. The problem with the version range is a little bit like the warnings clean problem. Because if you there's a couple ways to do a version range. So you can do version range saying, I've only tested up to this, and you should fail to compile if it's newer than this version. I find that a little restrictive.
No, I mean, the syntax here, in the minimum required version, you can give ... and then the upper.
Yeah, thanks for explaining. I should have said that. So in CMake, minimum required, you can set the version, and you can do like a range. So you can say 3.25 ... 3.31 or something. The problem with that is, one, if your project worked fine in 4.0, why would you set 3.31 and not let them build with 4.0? I don't see a reason for that. I mean, it's an option. The other thing you could do is you could just set it 3.25 ... 99.99. And what you're saying is like, always take the latest like feature flags whenever. But that, again, like if they did do a breaking change, you'd be just broken when someone upgraded the CMake program. So those are the trade-offs. So we're all engineers, we know trade-offs. So think about those trade-offs. I think this is the trade-off I think most people would like the best. But I'm not as opinionated about that, I guess. But do keep the lower end of the range bump. That I'm pretty opinionated about.
So how do you do? How would you handle if your CMake file, like, I support 3.25. I might not support 3.26, and 3.26 comes out and it's got something my make file breaks on.
If that's a bug, you can give that bug to CMake. Like they'll always set a feature flag to make sure that doesn't happen.
Well, what if they deprecated something like catastrophic?
Almost always it'll be a warning.
Okay.
And sometimes you won't get that warning unless you're bumping the minimum. That's why I say you're going to want to do that.
I think the question is basically about policies.
Policies?
What is CMake minimum required?
Yeah, I'm avoiding going to a lot more detailed thing, but there's a lot of very granular feature flags for all of these things that they change and break to the extent that they can or don't forget to. So if you ever get a break unexpectedly from a CMake version bump, the program version bump, it's probably a bug. You just file a report. They'll probably fix it. They'll probably add a feature flag for that, and then your old version thing will work again. But you need to bump your version because that thing broke. You need to go fix it, right? Like it's probably old and busted, and you don't want it anyway. And CMake's trying to be helpful. Yep. But if you set it to 2 point whatever, you're not getting the last decade of like things that are deprecated or otherwise were broken and they fixed and stuff, right? Yeah.
Yeah. The way I try and think of it or explain it to people, you're asking whatever CMake version you're running to be bug compatible with 3.25.
Right.
Literally bug compatible.
As much as they can, it's bug compatible with 3.25. And you don't want the 3.25 bugs. You want the
fixes.
You want the fixes, right? Yeah. And you want the deprecation notices and all that stuff. So the next interesting line will be your project command. This is not that interesting a command. I'd rather move on to other things. Other than you can read the docs. You can set a version in there. That's nice. It's important to use it though. Like one of the bigger mistakes I see people make is to forget to put this in there or just not know that you're supposed to. And you get a kind of a weird error message if you do. So if you get something about CMake in a scripted mode and being confused, that's what that means. It just meant it should be spelled. You probably forgot to add your project statement. Among the things this project statement does is it actually loads those toolchain files. So it's a very important thing to put very early in your project. It's possible to put things above the project command, and sometimes you'll see documentation about that. Take that with a grain of salt. For the most part, for the most part, you want to put that in your stuff in your toolchain file anyway, in my opinion, or in environment variables or something. Always enable the test target. I said you should do that. Here's how you do it. Just unconditionally put include ctest in your project. You could also spell it enable testing. They both, for the purposes of this talk, are close enough. There are some differences, but you'll need to get to an intermediate to advanced CMake talk to see why those are interesting. So that's pretty much it. Those are the interesting parts in the top level CMake list of text. The rest is going to be just adding the rest of your project. By the way, you can put all the rest of this stuff I'm talking about in your top level CMake if you want. I recommend not, because it's just nicer organized if you put your libraries in one directory and your test in another or something. Right? Have a directory structure and stick to it. If you want to conditionally, like I said, add some things, this is the line of code. These are the lines of code that conditionally add those examples like I was telling you about. So you can just have a conditional on that variable and add that subdirectory. Not a big deal. By the way, if you want to know the syntax for how the if statement's evaluated, there is a fairly thorough reference doc for the if statement in CMake. You can read it. It'll explain that this is one of the forms that you can use. But notice there's no curly braces, no dollar signs. Just that's the nice way to spell it. So the library part. So I'm going to change directories. I'm not in the top level CMake list anymore. I'm in the subdirectory that includes the library where the library is defined. We're going to define a library. We're going to do it twice. It's such a good thing to do. We're going to add the library. The first statement actually does what you think it might, is define that there is a library that is built in this project. The second one makes an alias for that library using the CMake preferred namespace target-oriented spelling. You're going to want to do both because the first one actually sets up your build rules and all that sort of thing. And you're going to use it in the rest of this directory and nowhere else. And then the second one is for everything outside this directory, including outside of your project when someone wants to depend on you. And it just sets up a nice, this is a design pattern you see in some kinds of coding where you have like an internal interface and an external interface. And then things are nice, just nicer in general for certain kinds of design patterns when you can treat those separately. And this is one of those cases. As I say, pick globally unique names. That's why we have Beam and Exemplar, not just Exemplar, or not just Beam or not Core. Like, don't pick a target named unit test. Name it something unit test as much as possible. I didn't use the static option. You'll see that in a lot of examples. For no particular reason, you don't need to do that. That's the default, by the way. And there is a CMake feature, build shared libs, to help you control whether you're building shared or static. And you probably should just support that and not break that workflow. Target sources is how you can associate source files with those targets. So pretty straightforward. It's worth noting that these target _ commands work like this. You'll end up passing in the name of the target. Again, the one from inside the directory, so I'm using the dot version. And then there's some qualifiers maybe, and then some properties to pass in. So we're just associating source files with the library in this case. There's a node in a graph that has properties on it. And those properties include, yes, they're source files. Exactly these source files. For source file adding, it's almost always private. Like, why would you, there is exotic use cases where you want someone that depends on you to build source files, but please don't do that. You probably don't need to. And there's another target sources. So this is something I definitely don't see recommended enough. I've seen it in a few talks in the last couple of years. But this is the way you really, really want to declare your header files from now on. If you don't remember anything else from this talk, this might be the best thing to remember. This is great. This is something that, again, Kent Ware and Bloomberg teamed up on this. We were just like, hey, the model for this kind of stinks. We should improve it. And everyone was like, yeah, we should. So this is it. Again, target _. So the first line is the name of the library. And then we're saying we're going to have a public setting. So the people that depend on me are going to be affected by this change because it's public, not private, right? So we're making a file set headers. That means I have a set of headers. We're going to set a base directory. So the headers are in this layout way over in the include directory, not in the source directory. So that's the relative path to that. That's the base directory for those headers. That is a very important piece of information. It lets CMake know that where your include directories are going to be, unsurprisingly, but it also knows like how they're included because it can use it could do the directory relative math to say, oh, there's a Beam and Exemplar identity.hpp thing. That needs to be coherent. I'll just install it like that, which is what you want.
Is it necessary that you put the absolute path in the files section? Because you already gave an absolute path as base directory.
And I missed a $sign on that line 16 too. And in the real code, it's there. What? So absolute path?
Because you gave an absolute path for the base directory.
Yeah.
Do you also need to give the files as an absolute path?
I may not. If you want to give me that PR, if it passes, I'll merge it. Yeah. I think you do, though. I'm pretty sure you do because it does do the directory math. Yeah.
Yeah, it does, because
you can have more than one base dir.
It subtracts the base dirs, which might be more than one, from the strings in the files list.
Yeah.
And it's a strict match.
Yeah, and it's opinionated about like not having overlapping base directories because how would you do the math? How would you do the file system algebra.
So there can be multiple base directories.
Yeah, I would probably prefer to just have more than one statement personally, but yeah, we have done that where we have like code generators that will call this to say the code generator made headers, and we're going to generate headers associated with the target. Yep.
So I've been curious about this, which is generally what I do for CMake is I'll add subdirectories for my source files where I define my library, and then it looks like this is where, hey, I've defined my library, I'm adding my headers that I want to include here too. Why wouldn't I go ahead and add subdirectory to my include directory and have a CMake listed file in there that actually adds it to my library?
You can. There's fewer foot guns if you do. If you do that, if you get it to work, it's fine. But there are foot guns involving like especially if you use a relative path. Was that relative to the add library, or was it relative to the CMake list you were in? And like that, like you'll find it pretty quick. Probably, but like those are the things that happen. If you don't want to do it this way, the other way that makes the most sense is to actually in the source directory or even the top level directory, do the add library and then just have everything relative from that directory all the way down and not do the ... stuff. Does that make sense? Or have a simpler directory structure that's more CMake friendly and just have them all in the same directory or something. But this is the BMA project wanted the pickaxe or the pitchfork layout, so that's what we got. Yeah.
Is there a distinction to be made between CMake current source dir and CMake current list dir?
Yes, it's nuanced. So I definitely have the reference docs open if you're trying to make that decision. But usually in a CMake list.txt, this is the one you want, is the short version. We have Wincing in the audience. It could vary, I guess. But
it depends answer.
It depends answer.
Yeah.
This works for this use case. That's a nuance that probably isn't all that. If it works, you're probably fine, I think. It's not. There are not foot guns there, I don't think. So does that make sense? Like the list or source dir probably matters more if you're writing CMake modules that other people are calling, kind of thing. Yeah.
Just curious. So eventually, this project will need to be installed, and at the install step, it's going to use the file set of headers to know that hey, what I'm going to do is I'm going to have this. So the includes also for informing how to build it, but also has to figure out what to package into it. Like, will it preserve that directory structure? Like, how does it know how to preserve the directory structure?
Well, because it does the file system algebra and says, oh, you need beam and exemplar identity as such.
But it will
no, it
preserve.
Doesn't. And that's the important thing.
It doesn't. What?
Install doesn't care where your files came from.
I know it doesn't care where they came
it's
from.
It's going to take the file beam exemplar identity.hpp and install it where you told it to install.
Yeah, I thought that's what I said.
Yeah. Well, what I'm saying is, will it preserve that directory structure from include through, or just like
if you have multiple base directories, they get merged to a single one if you install.
Well, I don't understand the question.
I guess,
but when I do show the layout later for the install directory. If not, might answer your question. So we can move on. And if you still have the question at that point, we can get back to it.
Okay, thank you.
So I think it hit on these points. So, and for my CppNow audience, it is a data structure that is like monadic in several ways, and it is just nicer to support. And we can add more features, and we have already added more features. For instance, this is your first set target properties you've seen in this talk. This is a thing you could do to explicitly set a property on the target instead of like the implicit ones like file set headers and target sources where it says like under the hood, it knows there's properties that set. This is like, no, I'm going to set the property. It's a key value store. I'm setting keys and values. This one with the arrow next to it, what this does is it builds your headers, give or take, in the terms of the library the headers belong to. So you can know if your headers parse. Like very few build systems support this, especially if you invented your own build system. Will support this. And it'll detect things like, oops, you forgot to include std vector. You used std vector, but you didn't include the header for std vector, right? Like in other contexts, you won't get that error because someone else included std vector before your thing was ever included, right? So, but this will find that because there's no other thing that was included before you. You just have the header.
Oh, that's awesome.
You answered my question.
Yeah. So you want this. And what it does is it defines, does a couple things, but the interesting thing is it defines a new target. You can run this target in your CI system to build those headers directly. Those headers will show up in your compile commands JSON as well. So you can claim tidy your headers in terms of how that library is defined as well. So the data structure has power. Please like lean into this. That's why I want people to get excited about these kinds of changes. And we want this for your package management, which is why we're working on packaging standards that can also open up all kinds of doors to cool stuff.
Just a question. That property works on with the header sets, right? It will not
This one works. Yeah, if you don't have header sets, it's not going to do anything. Yeah.
Why is there an export name here? So
More on that later. Good question. So we're getting into layout parts, right? So this is what we want. We want a lib directory. So this is a POSIX style system, right? We want a lib directory with Beam and Exemplar installed. We also maybe want to do a debug build. So let's put that in the debug subdirectory. There's a few layouts that expect this. Let's just put it at that. That's what we're shooting for. Beam and Exemplar, the name comes from the add library that we already saw, that first form of it, right? And it's worth noting it's an external interface. Some build systems will want to use -l beam.exemplar as an identifier of how to link your project. So be intentional about that name. That's why I brought that up. All right, that's a lot of lines. Let's break it down. I saw a sigh of relief in the front row. So again, it's an install. It's a target. It's operating on a target in this case. So there's targets that you can list. You could give more than one, but probably just want to do one at a time. These get complicated enough. We're also going to give it a component. Component's an interesting feature. Install actually, if you use the install form I recommended, you can choose specific components for your install, meaning subsets of the installation. So I recommend, like with your library, everything that should get installed with the library should go on that same component. Might as well give it the same name as your library. It's just a correlation ID though. You could put foobar as long as you're consistent. Just your users would be like, why did you name it foobar? Export is not the same as that other export name. It's a different correlation ID. It's more complicated than it needs to be, but that's the way it is. Destination is where you're putting it in the install tree. So this would be your lib in your lib debug, right? That's called a generator expression. You can look at the docs for generator expressions. It's just kind of a Lispy syntax for if it's debug, add an extra debug at the end, right? I expect if we're still spelling this in a year at the Beam repo, then we probably missed some features we should have been working on. But this is the vanilla CMake way to express what we're trying to do here. It's very important when you're doing destination settings in your installs that you follow the CMake recommended doc in the reference docs guidelines to use CMake install _* settings, because that is an interface that your users will use. If they don't want to install a lib, if they want to install a lib64 or lib x86 unknown GNU or something like that, that's something people configure. So if you hard code lib as such, instead of using this variable, you just broke that workflow. So this is important. It's in the docs. Nobody reads the docs, so you saw it here too. So little footnote, you need to define those. They're not defined by default. You can include GNU installers to bring them in. You talk to Vito in the hallway afterwards about how he wants to fix this weird word, because it is weird that you might use that on Windows. That's how it's spelled. Include a layout. This is the include layout. Maybe this might answer some of your questions. This is what we're looking for. And again, it's going to support the include statements that we talked about. We want the include statements to be spelled consistently like this. This layout supports that. So that's the next and the last line in the install command, is that we're going to say, yeah, that file set, remember that file set we talked about? Go ahead and install that sucker, right? And then again, there's another destination, so we're going to use another CMake install variable, and it's the include dir one. Unsurprisingly, how would you know it's the include dir one? You go read the docs for GNU install dirs, and it's pretty clear, right? By the way, these have good default settings. You don't have to be this verbose if you're okay with the default settings. The Beam and Exemplar project wanted the debug subdir, so it's a little more complicated, but not too bad. This is the CMake support part. I might go a little faster through this because it might be more interesting to hit on Q&A, I would expect. But if you want to support a debug flavor, maybe a release flavor, you want to support a top-level entry point, you want to support version settings, you would need one of each of these files. That's just the way it works right now. Again, we're working on standards in this space to simplify this dramatically. For now, this is but the good news is, if you use find package, if you use the exports I'm talking about here, we expect you'll just be able to seamlessly shift from this more complicated thing to the simpler thing as time goes on. I'll go a little faster because I expect you're going to be a little less interested at this point, but we can talk in more detail if you want. What this does is it generates a file for the top level entry point. So this is when you call find package in CMake, it basically hot loads some code that someone else shipped to your project. And this is the entry point, the config.cmake file. It's beam exemplar config.cmake. That's the entry point. If you read the docs for find package, it talks about all the ways that these things work, and this is the preferred one. This is another code gen step where it's generating CMake for the version file, right? And you would support this if you wanted people to be able to spell find package, beam an exemplar, and give the version number that they expect. I don't personally find the need to use the version qualifier, but if you want it, that's how it works. That's how you'd support it. This is an install command, and it just installs those two files. Nothing too crazy. Again, destination shows up. Again, use the CMake install variable for libdir CMake beam and exemplar to put it in that install tree the way I laid it out. There's other install trees you can use. The find package docs give you some other options, but this is good. Did I get that far? Yeah, okay. And then this is the last and final CMake list. It can be more than one, but it'll define your targets basically in CMake code. So it'll define at like a version of your add library command, but for the people that's importing your code. It will support debug, and if you have debug, release if you have release, that sort of thing. The most interesting part of this, I think, is the namespace. So that's why I have this slide, if nothing else. The namespace is actually really important. That is the beam : from the beam : exemplar alias library name that we were talking about. If you get that wrong, people call find package. Your users might, if you named it foobar, your users would have to say find package beam exemplar, foobar : exemplar. So it's that thing, right? So get that right. And then back to that slide that was asked about earlier, that's the exemplar part after the beam exemplar. All right? So that's why you set that property way back there. You could probably set it later. We didn't. Just so it's like closer together.
Okay. Again,
all right.
Stop here.
Yeah.
Okay, so going to this whole thing. In order for find package to work, it's sort of assuming that in your libs directory there is a CMake directory that has all the stuff that find package needs to upload it.
There's a few other ways to do it, but that's one of the ways that works.
That's one of the ways that works. And what this whole step is about, how you can generate that as part of your installation step.
You're doing code injection into someone else's CMake lists.
Right, but here's a question, which is, I noticed that we have, for example, they have the CMake in that you use. Could CMake generate that based? Could it sort of self-host everything and not pull in from an external record? It's already built, it's already been declared, and you say, here's my project. Why can't it also export the needed...
Why isn't there a simpler statement? Is that what you're trying to ask?
Yeah, why isn't there just one line that says, install my find
I
package
recommend if you find yourself typing this too much, and then I'll be proposing this in Beam as time goes on, that you probably need a CMake module for your directory structure patterns and shipping patterns, so that you're not doing the code over and over again. You should just have, internally at Bloomberg, we just say install my library as a command, and we just do what you say.
Oh, okay. So this is...
Also, this sucks, and come to my talk tomorrow, and I'll show you what we're trying to fix.
Some of the really good questions you have are as a room are intermediate to advanced topics. And Vito now knows to cover all of them. So Vito Gammarini is going to give a great talk about more in depth about why and what the hell and things like that.
Can we go back 2 slides? Because I saw Beeman does this, and I'm a little bit confused about it. So you have configure package config file. You can just tell me to screw off with this question. I assume your CMake.in has 2 lines in it. It has package in it, and at the bottom you have required components, and then you have your include targets, whatever. The only reason you're calling configure package file is because you have package in it. You only have package in it so that you can call the required components macro. Why?
It could probably, if you could simplify it, we'll take the PR.
Okay.
So everyone watch the Beeman repo. Vito's PR might make this even better.
Okay.
Right.
Can I ask a question? You said make a PR and we will take it.
Yeah.
The question
we'll talk about it.
Yeah. Well, let's assume it will be merged. But let's assume someone already used your template.
Yeah.
How you get updates?
That's another problem with having complicated CMake. You don't want to update that. So if there's more, it's even worse, right? So that part I agree. Again, if you have a CMake module, then you just version the module and everyone uses the new version.
Yeah.
That's the way I prefer it. There's other ways to. Other than that, there's not a silver bullet, honestly, to keep your CMake list text up to date. Code transformation on CMake is not great. So that's another reason to keep them as simple as possible and declarative as possible. Because like the properties of your project aren't going to change because someone else changed something, right? Like your library is not going to have more source files because somebody made a different decision, for example. So keep to like the facts of your project, and you're going to be more future-proof.
Yeah, but for example, like you're showing all these default variables, which is good by default, but some of them added in your version. So to be able to enable them, you need to have these good defaults somewhere shipped to you, right? Or you want to enable manually.
Are you talking about the options and stuff?
It's more for example,
the options always have the default be the relocatable, reproducible, like you could probably go anywhere and this works great, like kind of decisions. So like if you had something like a fuzz test that you may not want to run in production builds, that's where I'd start putting options on it. Where it's like, and then you would know, because you're wanting to run the fuzz test, that, okay, well, how do I turn on fuzz tests? And have a README that explains these things. Have CI so people can go see how you do it, and that kind of thing. Does that answer your question on options? Okay. All right, we're pretty good on time. Sorry for talking so fast. Next, we're going to define a test executable. That was the tough part of the talk. We're on downhill. We're going downhill from here. Changing directory again. Now we're in the test directory where all the tests are defined. We're going to pull in a dependency. Here's us pulling a dependency. Here's an example of that. So find package. You probably want to put required. What that gives you is a nice solid error message if it's not there. Otherwise, different things could happen depending on settings. It's usually a fickle idea if you're trying to like do cute things if gtest is or is not on the box. So I generally recommend against that. In fact, you can, especially if it's like one of your dependencies, then your users may be getting different builds of your entire library depending on like what they did in their provision step, which gets really confusing. Again, it defines gtest dependencies as gtest : gtest, and as was pointed out earlier, yes, it could be all lowercase and work fine. By the way, one of the reasons CMake is case insensitive, I believe, and Bill can disagree with me if I'm wrong, is that because it supports case insensitive file systems a lot, like things are funny. Like find package calls, like if you're on case insensitive file system and that name is part of the file name, like you don't have a lot of guarantees, right? So maybe we could do better. I don't know. Okay, so this is adding an executable. So there are more interesting executables out there than a unit test, but this is just to get you started. It's just like add library, but with an executable. It defines a target that is an executable. We're adding sources, a lot like with the library, in fact, almost identical to the library, right? The target link libraries is how we declare the dependency at the link level, right? We didn't actually have one of those in the library because Beam Exemplar is such a lightweight library, it doesn't have any. So now you see one. So you would add target link libraries, the thing that has the dependency, and then either private or public, and then a list of dependencies. And they can be space separated. I guess you could do semicolon separated, but why would you want to? And then you like the : versions because you get a nice error message if you forgot to import them. If you say gtest, if this was not in our code, we commented this out and then did this, you would get an error message saying, I cannot find a target for gtest : gtest, and that's your sign that you forgot to find package somewhere. Right, so that's nice. Which is also why you want to do the same thing for your users, provide a nice, consistent interface. Did I hit all this? I think I hit all this. Oh yeah, you can also add headers to the executables if you'd like. So you can still use file sets, even if you don't want to make them public. It's fine. Yeah.
Is there ever any reason why you would want public link libraries for an executable?
Not for an executable that I'm aware of. Maybe someone else has an interesting idea. It's worth noting though, for libraries, you almost always want it to be public. It is possible to have a private library dependency from a library. Again, it would be in the range of exotic. If you don't have a good reason, you probably just want public.
You're writing an ld.so replacer.
Yeah, okay. You're writing like a Python. You're reporting Python to CMake.
Yeah.
In which case, all hopes is lost already. They have the weird setup. Okay, so now we've defined the test target as an executable. We can actually wire it up to our test target. We defined a test executable. We can wire it up to our test target. In the case of specifically a gtest test, you can use a baked-in helper. That's really nice. It'll know it'll kind of scan, it'll use tricks. I'm hand waving because, again, whole other talk if you want to go to a lot of detail, but it'll use tricks to find basically all the tests as defined with your test macros. and wire them all up to C-test. So you can filter at that level. Like, well, when you want to run this test case, which is great for you if you want to filter. It's also great for your IDE if you want to do things like run exactly this one test and not the other ones in my little IDE workflow thing. All right. So, and that's pulled in from an include on Google test. It could be a fine package, but again, that's not how they designed it. The alternative, which we don't notice, there's no spyglass, magnifying glass in this because we didn't do this, but you could add test directly. And there's a lot of other options and properties you can set. Again, lots of docs on what you can do there. Lots of power tools in this, by the way. Craig Scott's done a lot of work on more advanced testing workflows, including like setups and teardowns and all kinds of cool stuff. Like it'll look like you can make a graph of test requirements and walk through it like topologically. It's kind of cool. But basics, you just say name and command, right? And if you do make test, this will run. All right, so we walk through all the code, all the CMake code in the Beaming exemplar. There's a few comments I skipped and a couple extra options, but that's basically it. So takeaways. Did I say you should have really simple CMake? Did I say that yet? You should. All right. Just a handful of statements per library. It seemed like a lot of code, but if you add it up statement-wise, there's like a dozen, like maybe 16 or something. It wasn't that bad. And like Vito and I think we can get rid of 5 or 10 someday, right? So it's not too bad. If you find yourself writing a non-trivial amount of CMake, and we're already asking this in the Q&A right now, right? Like, do I want to do this over and over? If the answer is no, then you probably need to find a better way, right? It's probably, and for the most part, the answer is be simpler, not be more complicated. And by the way, for CMake modules, I do have a 2019 talk called Modern CMake Modules about how to ship a CMake module so you can reuse it across projects if that's interesting. Again, I talked about the CMake workflow quite a bit and a lot less about like cool things you can do inside your CMake list.txt. So also weight that accordingly. Ask yourself first, is there a command setting for this I could add rather than implementing it in your CMake? Do not write a unique build system in the CMake language. That is not a great idea. CMake is a great build tool. Use it. And again, defer to tools with more context. CMake doesn't have the context to do what you would want it to do. You say, can't CMake just, and sometimes the answer is not really, because it's working and operating in the context of building one project. It can't see all the other, foot guns and foot cannons and things that are hanging around in the dependencies and stuff like that, right? You need something higher level to have already mapped that idea out and then brought it down to your CMake and set it up for success. So things that have more context. CMake presets have more context. I have a slide on that if y'all want me to get to that instead of Q&A. But it's ways to provide at least some default workflow that you like that save you typing. It won't solve all your problems, but it'll solve your 2 or 3 favorite workflows, make it nicer to spell. CI tooling, again, fat GitHub Actions is much better than fat CMake list.txt. And I understand how painful GitHub Actions can be, but even so. Again, I mentioned top-level make files, not the worst thing. Or just file, if you like just, that kind of thing is not a bad fit. Use a package manager for dependency management. They're very good at it. They have a lot of power tools. Like you can do top-to-bottom thread sanitized builds with all of your dependencies with a package manager. Kind of tricky to do with the CMake. And that's it. I have some bonus slides if you all want me to go to them, or we can do more Q&A. Thank you. All right, so bonus slides, I have some CPS previews, although Bill Hoffman has a full-length talk on CPS coming up later. If you're curious, if you turn on the CMake experimental features, this is what you're going to get out of the Beam and Exemplar project. Again, nice and declarative. You can see it's a data structure, right? It's not an algorithm per Sean's talk this morning, right? And then this is my take on presets. One of the challenges with presets that's worth noting before you get into it too heavy and get your hopes all built up is that like there's a lot of different things you might want to do together, and it goes combinatorial. So once you start multiplying out the workflow space that you might want to pursue, it's impossible to list that in a JSON file. So you need something that is more expressive somehow, and that thing isn't presets, at least not yet.
So just to provide context for this, we added a preset support for Exemplar, and just LVM, GNU, and MSVC compiler with debug and release flavor with minimum preset actual configuration is about 150 lines of JSON code. We were even talking about generating that preset file when we have package managers. So the combination explosion is very, very terrific.
We probably need to figure out a way to get the compiler selection into the toolchain files, but that's a whole other discussion.
Yeah, I mean, a combinatorial problem is a real thing. But my team definitely does make heavy use of this, just because if you have a large, complex build system and you want to make easy things easy, it's a very good way to do
It's
that.
worth noting that CMake 2.0 will generate you presets files. Then that might be a sweet spot. It's like you have a more context-aware thing, hand you presets for your build environment. And we do that in Bloomberg in a couple places too, where it works pretty well. Where we don't use, I think we use build types. But anyways, it's good to have more context-aware things to say, oh, you have thread sanitizing workflows available. Let's go ahead and add that to the list of things that are available. Kind of thing.
You can also define workflows and then chain together multiple actions in one CMake command.
Right. There is a workflow, preset workflow, which is even less typing because you don't want to type build -- preset. You just want, can I just have one command? And that's what that does. But again, you could do that with a make file or a just file. So, anyway. I got 5 more minutes. Any more questions or comments, complaints?
I got one in the back. So I noticed against your advice, Beeman Libraries making a list of the source in a directory and then having a for loop that will do the 2 commands.
That
are necessary for, say, each executable in the test directory.
You could.
Is there a better way to do that?
I'll have to look at the example. There's some more intermediate workflows that you can get into. Like you can, depends on what you're doing. But
I think it's just to separate.
There are
the
globbing things you can
files
do.
It's just to separate the list of files from. Again, there's like 2 commands per executable, right? Like you've got to register the dependencies, and then you've got to actually register the test.
I find that by the time you're writing a loop, it's a little bit like Sean Parent's point about like algorithms and loops. Like you probably want an algorithm, so let's write an algorithm and ship it in the CMake module. So like doing it, do what you got to do. We're software engineers, we know trade-offs, but you should treat loops as one of those things where it's like it's a form of technical debt. And like if you have a directory structure that's great and a project structure that's great, why isn't it something everyone else can use with a quick couple lines? Why is it that something? Why does everyone else need to write that loop? Right?
Fair enough.
I feel guilty about this every time I touch the bit of code, but it's essentially like, okay, we've got a whole bunch of examples, each of which produces an executable named the same thing as the file that we're building, and writing the CMake module for the one in this one project. It's like, this would probably be the first CMake module we should ship to ourselves from infrastructure when we figure that out.
Yeah, it's funny how C++ engineers can be really particular about like the parameter passing style in their C++ code, and they'll like go to 8 hours a day trying to get that just right. And then they'll be like, yeah, but I'll go ahead and copy paste the CMake everywhere.
Yeah, it's like, it was better. It's slightly better than accidentally building what was one of them? Like pair example, except I gave it the either CPP file. Because I had to repeat a word twice. And
so again, that's why I gave my modules talk first, like 6 years ago. It's super powerful. People underestimate it. So we have examples inside Bloomberg where we have one schema file and one CMake file, and it's a whole library. And like there's nothing to wire up. And like there's stuff like that that's incredibly powerful. Like you should be able to do a whole protobuf library with 1 line of CMake. Like 2 lines. Find package the thing that does protobuf the right way, and then I'm a protobuf library. Like that should be it. Like you shouldn't have to have like lines and lines of but if it's on Tuesday and I want to do sanitizers and
it's the harder problem of how do we ship packages to ourselves, because I should, it's like okay, maybe this should be a function, but that's more
Right.
lines of code to write a
Yeah.
function instead of this
Well,
loop.
Yeah, and that's
If
not a
I
hard.
could write it
right.
once for the 5 projects using it, it's a win.
The good news is, as far as CMake is concerned, you can do any of the dependency management techniques you want, and find package will work fine.
Yeah.
The hard part is we're going to have to pick some things.
Yeah.
And I know I will probably support. I have like 4 ways to get CMake to get Beam and Exemplar to support modules like as dependencies. But like, are we going to support all 4? Or are we going to simplify? I don't know. Ben?
So you kind of made an anti-recommendation for CMake as a dependency manager. I think that's what I heard.
It's a dependency resolver. It's great, but is it like a dependency fetcher? It's.
Do you not think though that given the existence of fetch content in CPM that it's a desirable and inevitable fate that CMake will eventually subsume current package managers? Or not?
And again, like Sean, like when Sean Parent was giving his talk this morning about algorithms and data structures and STL and Stepanov's thoughts, and like I'm thinking like, yeah, like I think he even had a slide that was like designing, like building large systems or something like that, and I'm like, yeah, build systems, right? Like because we need nodes, we need monadic things, we need graphs we can walk through. The slide I have, if I can find it really quick. My talk from last year was trying to explain this in my terms, similar kinds of issues, but it's a nice, pretty graph one. Like we literally have graphs, and this is the meta graph of how the graphs stitch together, and we need to do transform operations between these graphs. So I can map from the nodes in the provide step to the nodes in the build environments, create a build environment, and then create the nodes in the resolve step and all that stuff. And if we mush this all together in procedural logic, then you're going to have that incidental data structures that are so hard to deal with. And that's why build systems and package management, like dependency management is so hard, because it's just a big pile of incidental data structures. And like you could just brute force it constantly, but we're not disciplined enough as a community to have that as an effective long-term solution to the problem, apparently. So when I'm advocating for this, and I think Vito will also in his talk, more structured, more declarative, more data structures and algorithms, like literally topological sorts. Literally, like, do I have cycles in this graph? Like they're not, it's math. Like and when people complain, it's like, I'm sorry, it's just math. I don't know what to tell you. Like the problem you want to solve requires certain kinds of premises, and that includes things like identity properties and transitive relationships and things like that.
But my question was, sure, absolutely.
Right.
My question is more like, why wouldn't people want one tool in their CI pipeline rather than 2?
I think eventually
is the fate.
I would like to get there, but we need to get this done so that we can have the high level tool that can just do the math to do what you want. Does that make sense? Like we need the rigor attached. There is great academic work in this where someone comes in and defines the monads with precision that would make Sean Parent's eyes sparkle with joy. Like I'm not that person, but one of you is. So please, but like there are like things to discover, not invent, about how build systems work. If that makes sense.
I comment on it.
Yeah.
So like if CMake say eventually consumes package manager responsibility, that is fine, it's great, but it stopped being like a zero system generator at that point. It would be cargo-like stuff. So, and this is cool.
Yeah, it already seems to be going down that path.
All right, we're a little over time. It sounds like we got a great hallway discussion already kicking off here. I appreciate everyone's time and attention. Thank you.